Hello everyone, today we are doing section 3.3, the law of cosines. The law of cosines is a theorem which connects sides of a triangle with angle between two sides. Let's set up the theorem. The theorem is going to look like this. C square, one of the sides of the triangle, equals a square plus b square minus 2ab cosine of c. I'm going to draw the triangle so we can see where this A, B, and C are going to happen and how everything looks. It works for any triangle, no matter what are the angles. So I'm going to start with labeling angle C, and across angle C sits side C, right? And sides A and B are just like adjacent to angle C. I'm going to prove this theorem, and first I'm going to draw a height in a triangle. Height is a vertical line which goes from the vertex across side B and crosses it under 90 degrees. This height is going to divide my triangle into two right triangles. I'm going to consider a right triangle which has C as hypotenuse, and I'm planning to use Pythagorean theorem. But to use Pythagorean theorem on that triangle, I'll need to know the sides. So I'm going to start with height. Height is going to be my first side of the triangle. And I'm going to find it from second triangle, which has hypotenuse A. So it's A and sine of angle C, right? We do know that hypotenuse multiplied by sine of C is going to give us opposite side, which is going to be H. Now, for using Pythagorean theorem, I'll need to find a little part of side B, which is my second side of right triangle. Then I'm going to do it by calculating B, the big side, minus the part of the B which is belonging to a second triangle, which is going to be A cosine of C. Now I'm going to apply Pythagorean theorem to the height and to this little b, which I labeled b1, and simplify it and get my cosine theorem formula. So c square, hypotenuse square, is equal h square plus b1 square, side h square and b1 square. I did not label b1 on my picture, but that's just a part which is like having a curvy bracket. So I'm going to place my h, and that's a sine of c, and square it, and then b minus a cosine of c, square it, and I'm going to open parentheses. So a sine of c are going to be just squared. Each factor is squared. For this one, I'm going to use the formula. I'm going to square the first term, and then minus 2 first term, second term, and the square of the second term. So let's see. It's going to be b square minus 2b a cosine of c, my product of first and second term, and then second term squared. Well, I'm going to simplify everything and combine terms with a together. You see that they are similar. They have a square, right? I'm going to actually take this a square outside of parentheses. So it's a sine square of c plus cosine square of c, and everyone is recognizing Pythagorean identity, right? Now I'm going to copy the rest of the terms, just plus b square minus 2b a cosine of c. Well, I recognize Pythagorean identity, so it equals to 1, so I'm going to just copy simplified version, which is going to be actually the law of cosines. Well, let's consider example of use of law of cosines. So example 1, let's imagine that somebody gives us sides A, sides B, and the angle between. Basically, they give us all the information on the right side of law of cosines, and they want us to calculate side C. and maybe kind of finish solving of the triangle. Calculate remaining angles, angle B and angle A. Well, usually, if we know everything from the right side of the theorem of cosines, we are going to substitute it and calculate side C. And that's what I'm going to do. So C squared equals A squared plus B squared minus 2AB cosine of C. And I'm just going to plug in my numbers. 4 is the square of 2 plus 3, which is going to give me 9. And then minus 2 by multiplied by 2 by 3 and cosine of 60 degrees. And I'm just going to add everything. That's 9 plus 4, 13, and 2 by 2 is 4 by 3 is 12, and cosine of 60 degrees, everyone remembers that stable value, that's cosine of pi over 3, which is equal to 1/2. Well, I'm going to combine these numbers together, and I'm going to get 13 minus 6, which is going to give me 7. That's not going to be side C yet, because that's C squared, right? But I'm going to extract the square root and get my C. Well, now I solved all 3 sides, and I'll just need to find 2 angles. Well, you can choose either angle A or B. Doesn't matter, I'm going to stick to angle A. And I'm going to use cosine theorem again. Just I'm going to use it to find the angle. Because I'm planning to find angle A, I'm going to turn the theorem so it has actually cosine of A, which means that the left side is going to be A squared. So A squared and B squared plus C squared minus 2BC cosine of A. I know from this formula everything except cosine of A. So that I'm going to solve it for cosine of A, substitute everything, and that's going to give me the final answer. So I'm moving B and C to the left side and dividing by negative 2BC, and that's going to give me cosine of A. So I'll plug in numbers. That's a 4 minus 9 minus 7. Square root of 7 squared is going to give me just 7, right? Divided over negative 2 by 3 and square root of 7 because it's just C, not the square root. Well, which is going to give me minus 12 in numerator. And it's going to give me minus 6 square roots of 7 in the denominator. So I'm going to cancel 2 minuses and divide by 6 and get 2 over square root of 7. So the angle is going to be cosine inverse of 2 over square root of 7. I'm plugging everything into my calculator and get the angle, which is going to be 40.9 degrees. Now, I do know angle C, I do know angle A. How do we find angle B? Question. Think of a second. Remember that we do have a triangle equation for angles, that sum of 3 angles in a triangle equals 180 degrees. I'm planning to use it. So A plus B plus C equals 180. From where I can find B? I do know A and C. So it's 180 minus A minus C. And that's going to be 180 minus 40.9 and minus 60, which is angle C. And that's going to give me 79.1. Okay, so my final answer for this problem is going to be angle A equals 40.9, angle B equals 79.1, and side C equals square root of 7. So we solved the problem. Okay. So we are going to move to example number 2 now. In example number 1, we were given two sides and angle between, so actually it was very obvious to use cosine theorem now. Imagine that somebody gives us all three sides and no angles at all. Like in example number 2, somebody gives us side A equals 4, side B equals 3, and side C equals 6. How should we work in this case? Well, guys, again, if you look at cosine theorem, you see that there are sides and angle, right? If you do know all sides, you can always find the angle. Same way we are doing in example 1. So I'm going to just write down that cosine of A formula, which comes from example 1. A squared minus B squared minus C squared divided over minus BC. And I'm going to plug in my numbers. 16 minus 9 minus 36 divided over minus 2 multiplied by 3 multiplied by 6, which is going to give me 29 over 36. Now I'm going to calculate cosine inverse of 29 over 36 and get my angle A, my first angle. It's going to be about 36 degrees. What I'm going to do next? Next, I'll need to calculate one more angle. And again, I'm going to use cosine theorem. You can choose which angle you calculate. It's not necessary to start with angle A. You can start with angle B or C. I'm planning to calculate angle B using cosine theorem. And after that, use the property of triangle to have sum of angles equals 180 degrees, calculate remaining angle C. So to calculate angle B, I'm going to turn the theorem around side B. So it's B squared equals A squared plus C squared minus 2AC cosine of B. And I'm going to get a similar formula for cosine of B. Which is going to be B squared minus A squared minus C squared over negative 2AC. And I'm going to plug in my numbers. So it's going to be 9 minus 16 minus 36 divided over minus 2 by 4 by 6 equals 43 over 48. So I'm going to plug it into my calculator and find that B equals cosine inverse of 43 over 48, and that's about 26 degrees. Well, now I do know two angles. I just need to find angle number 3, right? I know that my first angle is 36 and second is 26. So I'll just subtract them for 180 and get my angle C. C equals 180 minus A minus B, and that's going to be 180 minus 36 minus 26 degrees, and that's going to be 118 degrees. Okay, we solved one more problem. Now, I want you to try a problem on your own. So, I'm going to give you a problem, and I'll ask you to work on it for 5 minutes. I think my camera is, or my piece of paper shifted a little bit. I'm going to tell you what I'm writing down over there. It's B equals 1, C equals 3, and angle A equals 80 degrees. And I'm asking you to find sides A, and two angles B and C. Sorry that you cannot see it. I'm going to attach notes of this lecture so you can always find what is missing there. I moved a little bit my piece of paper and I cannot see the full screen now. Okay, I'm going to count 1, 2, 3, 4, 5. You can try the problem again. B equals 1, C equals 3, and A equals 80 degrees. And I'm going to start solution myself. So I'm going to use plain cosine's theorem. A square equals B square plus C square minus B C cosine of 80 degrees. And just plug everything in and calculate side A. And that's going to be 1 plus 9 minus 2 by 1 by 3 and cosine of 80 degrees, which is going to be approximately 8.958. I'm going to approximate it by 9. So what I'm getting is side A also equals 3, almost 3. It's a little bit less actually, right? But to make it more simple solution, it's almost 3. Okay. Interesting that my side C is also 3, so we are dealing with equilateral triangle. What I'm going to do next? Well, next I'll need to find, for example, angle B, and that's going to be again cosine's theorem. And the cosine of B is going to be B squared minus A squared over C squared minus 2AC. And I substitute all the numbers, so it's going to be 1 minus 9 divided over minus 2, 3 multiplied by 3. And that's going to give me negative 17 in numerator divided over negative 18, which is going to give me 17 over 18. Well, now I'm going to just calculate cosine inverse of this negative 17 over 18, and that's going to be 19 degrees approximately. So now I do know angle A, which is 90 degrees, and angle B, which is 19 degrees. I can just find angle C using the property of triangle and the sum of the angles in a triangle. So 19 degrees plus 80 degrees plus C equals 180, from where C equals 180 minus 19 minus 80, or 81 degrees. Okay, that's all from this section. Do your homework and ask me questions if you have any.